Hi everybody, this is a video I'm doing on the big solar storms that are happening. They're bringing in the northern lights displays. This comes from Norway. As you see in this video, all these beautiful lights displays going on that are caused by the radiation, the solar radiation, in the from our sun, and this is just looking for a couple minutes so you can just watch the display, and I have some other things that I need to show you. I think that's really awesome. More awesome display. Isn't it cool? It's really cool. Okay. The title of this article comes from space.com, and it's a space hurricane. Huge solar storm is pounding the Earth right now. So we're feeling some things, power outages in some places. Nothing really severe. It's just, an effect that happens with these really strong CMEs. This is a wave of charged particles from an intense solar storm is plummeting the Earth right now, which may trigger stunning aurora displays and cause minor disruptions to satellites over the next 2 days, NASA said. The storms began with a powerful solar flare that erupted on the sun yesterday, January the 23rd, blasting a stream of charged particles toward the Earth, and the electromagnetic burst called a coronal mass ejection, or CME, hit the Earth at 9:31 a.m. Eastern Time. According to scientists at the Space Weather Center at the NASA's Goddard Space Flight Center in Greenbelt, Maryland. And it's a minor to moderate storm, says a researcher at the Space Weather Center. Probably in the next 10 hours or so, people at high latitudes can see the auroras. This could maybe cause communication errors at the pole caps, but the magnetic activities are probably not too strong. And this is for parts of Europe already. There's further points to the east. We should expect to see some strong magnetic storm conditions. And there is a very good chance tonight that we'll be seeing some very typical aurora occurs at the and typically the auroras occur at the relatively high latitudes, but of events like this, you could get auroras down at mid to low latitudes. And as you see here, some of the mass ejections that are coming out of the sun right now. This is when a coronal ejection does hit Earth, it can trigger powerful geomagnetic storms as charged particles in the fields within it interact with the planet's magnetic field lines, and this can amp up normal displays of Earth's auroras, known as the northern and southern lights. But a strong CME aimed directly at Earth can also cause disruptions to satellites in orbit, as well as power grids and communication infrastructures on the ground. So yesterday's solar flare set off an extremely fast CME, and the associated radiation storm was the strongest since 2005. But the ejected cloud of plasma and charged particles were not directly aimed at Earth and is hitting the planet at an angle instead. This glancing blow will likely lessen any impacts on the Earth. Earth's magnetic fields serve as a shield and pretty much shield the radiation so that it doesn't penetrate that deep. It's like a car collision head on or off to the side. A CME is like that too. For this one, if it was a direct hit, Earth would receive a much stronger impact, and this one was on an angle towards higher latitudes and a little off the ecliptic. Otherwise it would have been a much stronger impact. Since the storm does rank as the biggest space radiation event in about 7 years, it's not as big as some of the big historic storms, but the chance is re-intensification is still possible because the active spot on the sun that created the initial havoc could go off again. And I'll leave the link to all of this so you can examine these pictures, and there's also links going to other pages as well, so you can read further. And this does also take you to other just picture shows as well, and the anatomy of there's a map there of anatomy of a solar flare and such, and how they're created. Yeah. Okay, this is the picture of our angry sun, how it looks like with, it looks like a flash of a flare, like a star there. And we're having a good storm right now. Okay, the first one that was recorded was back as far as 1859, and it was called the Carrington event, and that was first documented event of a solar flare that impacted Earth. The event occurred at 11:18 a.m. on September 1st and was named after Richard Carrington, the solar astronomer who witnessed the event through his private observatory telescope and sketched the sunspots at the time. And the flare was the largest documented solar storm in the last 500 years. And according to NOAA, the Carrington solar storm event sparked major aurora displays that were visible as far as south as the Caribbean, and it was also caused several interruptions in global telegraph communications, even shocking some telegram operators and sparking fires when discharges from the lines ignited telegraph paper, according to a NASA description. And that's pretty hot. And the Bible says that the sun will scorch men in the end days. So it'll be that hot. If it scorched this paper, on the earth like that, yeah, sounds like it's pretty hot. 1972 is a solar flare versus AT&T. says the major solar flare that erupted on August the 4th, 1972, knocked out long-distance phone communications across some states, including Illinois, according to NASA account. And that AT&T was to redesign its power system for transatlantic cables. In 1989, major power failures from solar flares occurred. This is in March of 1989. A powerful solar flare set off a major March 13th power blackout in Canada that left 6 million people without electricity for 9 hours. It says the flare disrupted the electric power transmission from Hydro-Quebec generating station, and then melted some of the power transformers in New Jersey. This solar flare was nowhere near the same scale as the Carrington event. In the year 2000, Bastille Day event. The Bastille Day event takes its name from the French national holiday, since it occurred the same day on July 14th, 2000. This was a major solar eruption that registered an X5 on the scale of solar flares. The Bastille event caused some satellites to short circuit and led some of the radio to some radio blackouts. It remained one of the most highly observed solar storm events, those most powerful flares since 1989. 2003, the ultra-powerful Halloween sunstorm. Okay, on October the 28th, 2003, the sun unleashed a whopper of a solar flare. The intense sunstorm was so strong that it overwhelmed the spacecraft sensor measuring it. The sensor topped out X28, already a massive flare, but later analyzed found that the flare reached a peak strength of about X45. And the solar storm was part of a string of at least 9 major flares over a 2-week period. And that will take you to a link. Okay, on 2006, there was X-ray sun flare for Christmas. Okay, this one was a major X-class solar flare that erupted on the sun on December the 5th, 2006. And it registered a powerful X9 on the space weather scale. This storm from the sun disrupted satellite to ground communications and global positioning system, the GPS navigation signals, for about 10 minutes, according to the NASA description. The sunstorm was so powerful it actually damaged the solar X-ray imager instrument on the GOES 13 satellite that snapped its picture. And that's it on that. So yeah, so that just gives you an idea, you know, is more intense as time goes on. These storms get more intense, which means, you know, we stand a chance of our power grids being knocked out. And I'm getting close to the end, you guys. So until next time, y'all take care, and God bless you guys. Jesus love you, and so do I. Bye-bye now.